Okay, this is the Unit 2 test corrections for the FRQ. Okay, so the first question was to draw the forces using the arrows. So it's going to be force of air and force of gravity, and these two will be the same length. And then I got that part right. So part B is determining the units of the thing using the equation let's see. Yeah, you can use the equation they provide on the second part. F air is equal to mBg, and so this is going to be mass times acceleration. And then this is going to be, wait, no. Where was that other equation that they put? Okay, here. Include, that's the wrong equation. So it's going to be F air is equal to C RV squared, where C is a constant. So F air is still going to be mass times acceleration, C, and then R, that's in terms of meters, times V squared. So this is going to be mass times mass over second squared is equal to C times mass, or not mass here. Acceleration is meter, yeah, so meters per second. This will be in kilograms, this will be in meters, this will be in velocity is velocity, C is velocity again. It's going to be meters per second, so meters squared over seconds times C is equal to kilogram meters per second squared. Isolating C, dividing this other side, so times S over m squared. That takes off 1. That takes off 1. So you get kilograms over meter squared. And that's your answer. Okay, so part C. Let's see my work for this one. Okay, so my answer is V equals root F air over CR. And so that checks all boxes for this one. Recognizing that term of velocity, F air is equal to mBg. Yes, then yeah, and of course F air is equal to mBg, which is why this one is still correct. And then it has a V and an R, so that's the third point. And the sketch does show that it's there. So it has the radius on mine, and the force of air, and that checks out for the line. Okay, so part D. I didn't know we were allowed to use a motion sensor on this question, so I just found the velocity manually. Oh no, I did use a motion sensor. Okay, yeah. So yeah, I did have, let's see. Yeah, describing how to use appropriate equipment to measure the radius of 3 different parachutes. Yes, because you can use a meter stick to measure how many radius you want, how many different radiuses you want. Falling parachute, I include that this motion sensor, so yes, that is showing that you can find the velocity with the motion sensor. Describing a way to measure VT, then ensures measurements are taken when terminal speed has been reached. Yes, using the motion sensor, you can look at a graph. You can graph the data using the motion sensor. 1 point concern for attempting to reduce uncertainty averaging. And I didn't get a point for that because I forgot to include several trials. That's minus 1 here, and I also got a -1 for B because I didn't get that one. And then for part E, I could have just found the answers. Let's see, let's put the question. Terminal speed of block. Okay. And where the block should rest. Yeah. Okay, where it reaches a constant speed, and that's called terminal speed. Okay. So you can just choose random points for this one. Or you find when the, because the time interval changes from, it increases by 0.1 seconds. So you just need to find when these heights are remaining constant. So it's going to be from 0.63 to 0.23. So you can just find any of those values. So 0.50, 0.63. That's going to be my first point, and 0.70, 0.23 is going to be my next point. So x1, y1, x2, y2. So 0.23 minus 0.63 over 0.70 minus 0.50. And that's going to get you an answer of 0.2. Of 2, actually. So yeah, that's how you do E, and I did not get that point on the test. And so in total, I got a 9 out of 12 because I missed a point on part B, a point on part D, and a point on